All right, chapter 10, the final chapter in intermediate algebra, right? And, unusual circumstances make it to where you have to learn by watching and listening videos, but hey, that's how it goes. So we're talking about the square root, and the square root of a number, like say 25, comes from the idea that this is the same thing as 5. So square root of 25 is because when we thought about from before, 5 squared was 25. Well, now we're going to go backwards, and we're going to say the square root of 25 is 5. So it's really just going backwards of squaring, square root. Okay, so that's why square root of 25 is 5. And you have a calculator that can do that for you as well. That's number 1. But number 2 brings up one of the first problems of the square root, and that is taking the square root of a negative number. So what I'm asking myself is, what number times itself, because that's what I did here, I found what number times itself gave me 25. Well, that was 5. What number times itself gives me a negative answer? Well, there is no such number. Because if it was a positive number times itself, there would be positive times positive, and that would be a positive answer. If it was a negative number, it would be a negative times a negative, and that would be a positive answer as well. And the answer is negative. So it's not possible to take the square root of a negative number in the real numbers. When you get to college algebra, you'll look at something slightly different. Now that, number 2, is not the same as number 3. Here, the negative is on the outside. So taking the square root of 9 is asking you, what times itself gave me 9? Well, that's 3, but the negative wasn't involved. So now when you write your answer, you'll put negative 3. So negative on the outside is cool. Negative on the inside, not cool. Oh, it says no sol. Whatever. And same thing goes for fractions. You just got to think about what times itself gave me that fraction. Or later on, you're going to learn that all you got to do is say what times itself gives me the top. Well, 1 times 1 gives me 1. And then what times itself gives me 16? Well, 4 times 4 gives me 16. Since he's positive, you're good. So that's the idea behind finding square roots. Now, cube roots in any, well, the first of these three are cube roots. And that's the idea that when we say like 2 to the third is equal to 8, that's the same thing as saying 2 is the cube root of 8. Right? So we're asking ourselves, what times itself 3 times gives me 8? So when it's the cube root of 27, I'm saying what times itself 3 times gives me 27? And that's 3, because 3 times 3 is 9, and then times 3 is 27. I don't know why I can't get this thing to be more balanced. All right, and then we come to the next question, which is, can we take the cube root of a negative number? We sure can. So we're asking ourselves, what times itself 3 times gives me a negative 216? Well, a negative times a negative is a positive, but then times a negative would be a negative again. So all we have to do is figure out what times itself 3 times gives me 216. And it might help to just go off to the side and go, okay, 2 times 2 times 2 is 8. So 2 goes to 8. 3 times 3 times 3 is 27. I learned that right here. 4 times 4 times 4 is 16 times 4, 64. 5 times 5 times 5 is 125. And then 6 times 6 times 6 is 36 times 6, which is 216. So it's this guy, but negative, because he's negative. Now, you don't have to do it this way. You can just use your calculator, but hey, what if you don't have a calculator on you, Having the cubes listed off like this might be helpful for you and you can keep going 7, 8, 9, 10 just to have them all, but they get pretty big. Cube root of 125, again, you can just take the cube root of 1. 1 times 1 times 1 is 1. And then the cube root of 125, which is 5. Okay? All right. Now, when it comes to higher order roots, like the 5th root of negative 1, then I just have to say, okay, well, what times itself 5 times gives me -1? And that's -1, right? Because a negative times itself 5 times will still be negative. So it's okay. And one thing that is in the notes is that odd root means negatives are okay. An even root means negatives are not okay. Okay, it's just a little from the notes for you. So for number 5, it was perfectly fine because it was a 5th root. But for number 8. And then for number 9, it's a 10th root of -1. That's going to be no solution because even root, negative's not okay. Because you can't multiply something by itself 10 times to give you a -1. It'd be a +1. All right. The other thing from this section, is this the last thing? No. Yeah, it is. So the last thing about this particular thing is that anytime you have the square root of something squared, so you have both the root and the power, and they match, then they cancel. But you can't have a negative answer because -6 squared is 36, positive 36, and the square root of positive 36 is 6. So it's not really that they're canceling, it's that you're doing one and then the other. Does that make sense? So -6 squared is positive 36, and then you're taking the square root of positive 36 to give you positive 6. So don't be fooled by negative powers if you have a square and a square root going on. I'm sorry, negative numbers. Here we have x plus 9 squared. And rather than multiplying this out by foiling and then taking the square root, which I can't do anyway, I'm just going to cancel that and put x plus 9. But here's the kicker. So x can be anything, right? What if it was -10? You don't know, but what if it was? Then your answer would be -1, and that's not okay. We can't have a negative number. So what I'm going to do is I'm going to put absolute value around it. With even roots that can't be negative, negatives are not okay, we have to put absolute values around anything with letters in them. That's the rule for that. All right, so for 12, we have a negative outside, so he's okay. And we have 49x to the 4th. So in this case, I got to think about to myself, okay, well, can I rewrite 49x to the 4th as something squared? Sure can. What about 7x squared? So this square would make 7 squared is 49, and then these two would multiply to give me 4. Well, this is the same thing. Now, these cancel. The negative is not involved. And then we have 7x squared. And since x is squared, we don't even need the absolute value, but you can put it in there if you want. So the answer is -7x squared. Okay? So anytime you get the square root and the square underneath it, they cancel. Or the square root with a square on the outside, they would cancel. Not that you saw that. All right, 13. We have cube root of x to the cube. Now here, the numbers match, the root and the power. So they're going to cancel as well, leaving you with x. But because it's odd, I don't need those absolute values. He could be negative if he wants to be. No restrictions. Odd roots are, free-for-alls. That is not the word I meant. Whatever. You know what I mean. No, you don't. Okay. Anyway, what I'm saying is that odd roots can be negative. And in this case, look, 7th root, 7th power, they cancel, and you're just left with -6. Like I said, it can be negative because it's an odd power, odd root. And number 15 is an even root. So now when we have a negative base number, these would cancel, but you got to put +2. +2, because it's an even root, we can't have negative answers. And that is 10.1.